All right, hey guys, this video is going to go through what an inverse function is and give you some tips and tricks on how to find an inverse function when we're working with linear functions. So first thing, an inverse function. Here's a couple definitions or some key points. It's a function that undoes the action of another function. Okay, so think about what this word inverse means. Like if I asked you, what's the inverse operation of addition? Well, what undoes addition? Subtraction. Or if I asked you what's the inverse operation of division, it would be multiplication. Okay, if I ask you what's the inverse operation of squaring something, it would be square rooting. So just like those are inverse operations, inverse functions is a function that undoes the other function or reverses it. We'll get to this in our next video, but another way to think about inverse functions is you reverse the inputs and the outputs. They're just kind of switched. So I will show you how this works today. All right, so we're going to try to write a function for this set of directions that I have here. So first thing it says is we are going to multiply by 6. So if I'm going to write my function, I'm going to say I have to start by multiplying whatever value I have by 6. So I'm going to write 6x. Okay, then it says I'm going to add 4. So I'm going to put a plus 4. And then I divide by 2. Now I have to divide that whole thing by 2. Whatever I got there, divide by 2. Here's my original function. Now let's think, what if we wanted to reverse this? Okay, if you wanted to reverse this function or find the inverse, you basically work backwards. Okay, so the first thing I originally started was divide by 2. So instead of dividing by 2, I'm going to multiply by 2. Okay, so I'm just going to kind of write that out. I'm going to multiply by 2. Okay, instead of adding 4, I'm going to subtract 4. So again, I'm working backwards. So I'm going up this way. Instead of multiplying by 6, I'm going to divide by 6. Okay, so let's see what we kind of end up with if I do this. So for my new function, I am going to multiply by 2. So I'm going to put 2x. Then I'm going to subtract 4. And then it says divide by 6. This would be my inverse function. So I basically undid everything that I did up here on the top. I undid it down here by doing the opposite operations. Now, the notation for that, to show the inverse function, is this. It's kind of got like a little -1 symbol. That's not an exponent. That just means it's the inverse, or you undid the original function. Now, later I'm going to show you a way that you can check to see if you did this correctly as well. So I'm going to show you another way that you can find the inverse of a function. You can use the way I just showed previously, or this will be a second way you can do it. So you might want to jot these notes down. So first thing, you guys know if I ever give you a function like this, f of x equals 2x plus 4, that's the same as saying y equals 2x plus 4. Okay, so if it helps you, you can rewrite, instead of putting f of x, you can actually change it to y equals 2x plus 4. Your second step is you are going to swap the x and y variables. So you see where this x is and where this y is? I'm going to flip-flop them. I'm going to put the x here. I'm going to put the y there. Okay, your next step is you are going to solve for y. So just like I normally solve an equation, I would like subtract 4. So I end up with x minus 4, and then I have 2y, and then I would divide by 2. Okay, oops, sorry. And then I would end up with y equals x minus 4 over 2. Okay, this is my inverse function. Now, lastly, you would want to rewrite it using inverse notation. Again, this is inverse notation. This is how you say this. That's why I have these quotation marks. You actually read that as f inverse. Okay, so on this last step here, I would actually write my f inverse equals, and then I could put my x minus 4 over 2. All right, so that is kind of a little trick to find the inverse function. All right, this little mini unit, we are only going to be working with linear functions and finding their inverses or undoing them. So we'll see what that looks like on a graph in the next video. But for now, I'm just going to kind of show you another one. So again, you could think right now, if you were going to write directions for somebody for this one, you could actually write them out yourself too. And you could say, okay, well, they multiplied by 3 and then they subtracted 10. Okay, some people like to just do it this way. And if this works better for you, do it this way. I'm going to do it both ways, this example. Okay, now that's my original function. If I want to find the inverse, I could just do the do it backwards. Instead of subtracting 10, I could say, well, I got to add 10. And then instead of multiplying by 3, I need to divide by 3. Okay, and let's see if I could write a function for that then. Well, if I have to add 10, I'd write x plus 10, and then I would need to divide by 3. So here's what I think my answer is going to be. Okay, this down here. Now, I'm going to try it the second way that I just showed you on the last slide. Okay, so first thing I'm going to do is rewrite this as y equals 3x minus 10. Okay, second thing you do is you swap the x and the y variables. So instead of a y, I'm going to put x here. Instead of an x here, I'm going to put a y. And now I just solve for y. Okay, so I'm going to add 10 to both sides. Add 10. I get x plus 10 equals 3y. And then I need to divide by 3. Divide this whole thing by 3. I end up with y equals x plus 10 over 3. Now, look at either way I did it, I got the same answer. Now, the last thing I do need to do is write it using inverse notation. So I'm going to put f inverse equals x plus 10 over 3. I just found my inverse function, or the function that undoes this original one. So these two functions are inverses or opposites. All right, let's do another one. I'm going to do it the second way for this one. So I'm going to replace this with y equals x minus 3 over 4. Okay, your next step, remember, switch the x and the y. So I'm going to put an x here. I'm going to put y minus 3 over 4. Okay, now to solve this, you have to kind of think you have to undo everything. So opposite of dividing by 4, you can times by 4. That cancels. Times this side by 4. Okay, so now I end up with 4x equals y minus 3. One last step, I just need to add 3 to both sides. Okay, so I end up, I'm just going to come up here with y equals 4x plus 3. Okay, my last step is to write it using inverse notation. So I'm going to write g inverse equals 4x plus 3. And there is my answer. Okay, and that's my inverse function. Now, I'm going to show you how you can check to make sure that you did it correctly. All right, so here are the two functions that I got. Now, here's a way to check to make sure you did the inverse correctly. So what you can do is you can choose any number to put in for x. You can choose anything you want. Now, when I'm going to plug something in here, this is what I think to myself. I need to be able to divide that top number by 4. So I'm going to think, okay, what can I divide by 4? Oh, maybe 20. So if I want this to be a 20, I need this to be a 23, because 23 minus 3, that would give me 20. So I am going to plug in a 23. So I'm going to do g of 23. So when you do g of 23, you plug in a 23 here, minus 3 divided by 4. Okay, if I work that out, I get 20 divided by 4, and I get a 5. Now, here's how you can check that you did it right. So when I plugged in a 23, g of 23, I got a 5. Now, in my inverse function, it should be the opposite. When I plug in a 5 now, I should get a 23. So you're going to take whatever you get here, I got 5, and I'm going to come put that in up in my inverse function. So I'm going to take that 5 and plug it in. I'm going to do the inverse of 5 and then see what I get. So I'm going to do 4 times 5 plus 3. Hopefully I get 23. Well, 4 times 5 is 20 plus 3 is 23. I know I did it correctly. So that is how you can check them. Okay, let's do one more. If I have m of x equals 3/4 x plus 5 halves. Again, you can rewrite it as y equals 3/4 x plus 5 halves. Okay, next step, you can do it using like the verbal description I did, or I'll just solve it the other way. Swap your x and your y. So I'm going to put 3/4 y plus 5 halves. Okay, a couple different ways you can do this. There's a lot of ways, but I'm going to try to get rid of my fractions. Just as a quick refresher for you guys, let's use fraction busting. I look at my denominators, 4 and 2. They both go into 4, so I'm going to times every single thing by 4. Okay, so over here I get 4x. Over here, the 4's are actually going to cancel, and I end up with 3y. Plus, over here, 5 times 4 is 20, divided by 2 is 10, so I end up with 10 there. So now I'm going to go from there. I'm going to subtract 10 from both sides. Okay, I get 4x minus 10 equals 3y. And then I'm going to divide everything by 3. So I end up with y equals 4x minus 10 divided by 3. Okay, and then finally, I'm going to just erase this y equals, and I am going to put my function, my inverse notation. Okay, and then I am done. All right, so let's do a quick check on this one. I'm going to pick a number I can easily find 3/4 of. So I'm just going to pick 4. So I'm going to do m of 4. Okay, so I'm going to plug in a 4 for the x for my check, and then plus 5/2. I'm just going to change that to a decimal, 2.5. Okay, so if I do 3/4 of 4, I end up with 3 plus 2.5 is 5.5. Okay, so when I plug it in, when I do m of 4, I end up with 5.5. Now I'm going to take that 5.5 and plug it in up here in my inverse function, and hopefully I get an output of 4 because that's what I started with. So I am going to do 4 times 5.5 minus 10 divided by 3. So again, I plugged in the 5.5. That's what I kind of plugged in. So I'm just going to grab my calculator. 4 times 5.5 is 22. Minus 10 is 12, and then divided by 3. 12 divided by 3 is 4. So I know I did this one correctly. So again, at the beginning of this video, I showed you that inverse functions, their inputs and outputs switch. Kind of notice this was my input, here was my output, and then in the inverse function, it switched. This was my input, this was my output. So the inputs and the outputs switch in an inverse function. All right, so after watching this video, hopefully you can write an inverse function when given a linear function. Okay, all the ones we have been doing have been linear, and that's what we're going to continue to work on. But after today, you should be able to write an inverse function and test if you actually did it correctly, if the inputs and the outputs switched in your two functions.